On pages 3 and 4 of our Unit 3 notes, we review solving inequalities. Now we solve inequalities just like we solve equations, using inverse operations to isolate the variable. In this particular case, we have 1/2 times x minus 2. So we isolate the variable by adding 2 to both sides. We have 1/2 x is less than 1. And now my final inverse operation would be dividing by 1/2. We've talked about the strategy of going straight to multiplying by the reciprocal because 2 times 1/2 is 1. So instead of writing divide by 1/2, which is the same as keep, change, flip, multiplying by 2, we can go ahead and multiply by the reciprocal. That is optional. In any case, our solution is x is less than 2. X is less than 2. Any number less than 2 is a member of our solution set, meaning any number less than 2 can be plugged into this inequality and will yield a true statement. For example, -2 is less than 2. 1/2 times -2 is -1. -1 minus 2 is -3. And -3 is in fact less than -1. Since we don't have an equal sign, 2 is not a member of my solution set. 1/2 times 2 is 1. 1 minus 2 is -1. And -1 is not less than -1. Sometimes you're asked to just determine if a particular value of x, such as 6, is a solution to the inequality. Now, one way to answer this question is to go ahead and solve the inequality and describe the entire solution set. The solution set to this inequality is any number x less than 2. Since 6 is not less than 2, it is not a solution to the inequality. So if I were to ask you a question like this, you could just plug the number into the solution and see if it's true. And it's not. So I solved the inequality. Any number less than 2 is a solution. 6 is not less than 2. Another way to answer this question is to just take the inequality and plug the possible solution in. Plug 6 in for x. 1/2 times 6 is 3. 3 minus 2 is 1. And then I look to see if plugging in that solution for x yields a true statement. Is 1/2 times 6 minus 2 less than -1? In this case, is 1 less than -1? No, it is not. 1 is not less than -1. That is not a true statement. So no, 6 is not a solution to 1/2 x minus 2 is less than -1. Again, that just means, does 6 make this inequality true? And it does not. So if I ask you a question like this, is a particular value a solution to the inequality? 2 ways to justify your answer. You can solve the inequality and see if that particular value falls into the solution set, or you can just plug it straight into the inequality and see if it yields a true statement. One detail of solving inequalities. So I'm going to subtract 3 from both sides. Divide by 2. Is that I always want your solution to have x on the left side. So I want you to always rewrite your solution as an inequality with the variable on the left. In this case, -2 is less than or equal to x. We're going to write the equivalent statement, -2 is less than or equal to x, as x is greater than or equal to -2. Again, this allows you to properly graph your variable, and it just is more, this is the accepted way to write an inequality with the variable on the left. So x is greater than or equal to -2, making sure that when you rewrite it, it is an equivalent inequality. So the alligator's eating the x here and here as well. The most important thing to remember when you are solving an inequality is that there's one difference with equations, and that is when you multiply or divide by a negative, then you must flip the inequality. That's just because of what happens when we divide by a negative number. Even though 4 is less than 8, -4 is greater than -8. So things just work differently on the other side of the number line. 4 is a small number, 8 is a bigger number, whereas negative 4 is a big number compared to negative 8. Same thing with multiplying by a negative number. 4 is less than 8, but just like we did there, negative 4 is greater than negative 8. So when we multiply or divide by a negative, that flips our sign. We go from positive to negative or negative to positive, and therefore my inequality relationship flips. When you multiply or divide by a negative, you need to flip the inequality symbol. Let's just do an example here. Subtracting 5, so we have negative 2x is less than or equal to 6. When I divide by negative 2, that is changing the sign of my answer, so I must flip my inequality on that step. That gives me a final solution of x is greater than or equal to negative 3. So inverse operations, just like an equation, but when I divide by a negative, I have to flip my inequality. Let's go ahead and do this example as well. So this is where kids tend to make small mistakes. So subtracting 8 from both sides, we have negative 10 is less than negative 5, x. Dividing by negative 5, we need to flip the inequality. We flipped the inequality from a less than to a greater than sign when we divided by negative 5. Now this is not flipping, it is rewriting. We still have to rewrite our solution with the variable on the left. This is not a flipping because it's an equivalent statement. 2 is greater than x. We can say that just meaning the same thing, x is less than 2. So solving this inequality, I had to do two things. I had to flip the inequality when I divided by a negative, and then I needed to rewrite the inequality to have the variable on the left.